one thing that I think is very important about this lesson, there's going to be one slide that looks like a Venn diagram, and I think that is the most important study tool that you will get for chapter 8. We're going to add to it with each lesson, and if you're asking my opinion, if you were a last minute cramming chapter 8, what would I use? There's this Venn diagram that we start today. Okay, rectangles, rhombuses, and square definitions. So a rectangle is a parallelogram. So first of all, you're going to notice that each one of these are parallelograms, which means everything that's true about a parallelogram is true for a rectangle, it's true for a rhombus, and it's true for a square. So everything we learned about the opposite angles being congruent, the consecutive angles being supplementary, about opposite sides being congruent, opposite angles being parallel, the diagonals bisecting each other, all those things are true for every one of these shapes. Yes, sir?
Just confirm a rhombus is like that shape that we've been using.
That's what we're going to talk about here in a minute. I'm going to be more specific here. So a rectangle, I think you guys know, it's a parallelogram with 4 right angles. So if you have a rectangle that has 4 right angles, then you can call it a rectangle, a parallelogram with 4 right angles. You can call it a rectangle, and that is an appropriate name for it. So, for example, I'm going to draw a shape. It is not inappropriate to call this shape a rectangle. But I don't think most people would call that a rectangle. What would most people call that? A square. But a square is a rectangle as well. It is definitely a square. It's also a rectangle. It's going to meet all the things that's true about a rectangle will also be true about this as well. Because look, that is a parallelogram that has 4 right angles. So it's a rectangle as well. But square is more specific. Now a rhombus is a parallelogram with 4 congruent sides. So now it is not a requirement to be a rhombus for it to have right angles. It never said it had to have right angles. So notice here, if I've got something that looks like this, that would be a rhombus. It's a parallelogram with 4 congruent sides. So when we get to a square, it's got 4 right angles, and it's got 4 congruent sides. I'm really hoping you're about to ask me the question I'm hoping.
What's the difference between a square and a rectangle?
Okay, well, so the main difference there is that was the question I was thinking, but that's a great question. A rectangle does not have to have 4 congruent sides. It doesn't have to have it to be it. It just needs 4 right angles. Like most rectangles when you were a kid, right? Remember when back in elementary school, you'd see a rectangle, something like this, and you'd be like, that's a rectangle. But you're right, that is a rectangle. It didn't have 4 congruent sides. It didn't need 4 congruent sides. It just needed the 4 right angles. Yes, ma'am?
Could a rhombus be a rectangle or no?
Could a rhombus be a rectangle? It could be, but not every rhombus is. The better question is a square a rhombus?
Yeah.
It's definitely a rhombus. So a square is a rhombus, and a square is a rectangle. If a rhombus and a rectangle had a baby, it would be a square, right? It's got the things that both of them have. It's got the right angles and it's got the congruent sides. It's got the properties of both parents there. So squares are have everything a rhombus has everything a rectangle is. A rhombus only needs the 4 congruent sides. A rectangle only needs the 4 right angles. All right, so here's the same things. If you want to identify something as a rhombus, it will be first of all, if a quadrilateral is a rhombus, if and only if it has 4 congruent sides. Notice 4 congruent sides there, then this would definitely be a rhombus. Then we get down to the rectangle. It's a quadrilateral. It'll be a rectangle if and only if it has 4 right angles. Okay, so I got a quadrilateral. It's got 4 right angles. Well, then it's definitely going to be a rectangle. Quadrilateral is a square if and only if it's a rhombus and a rectangle. So first it has to meet everything that was true for a rhombus, which means 4 congruent sides. And it has to meet everything that's true about a rectangle, which was 4 right angles. So you can only call it a square if it's a rhombus and if it's a rectangle. Yes, ma'am?
So when you're talking about a rectangle, in order for it to be a parallelogram, doesn't it need to the opposite side need to be congruent?
Well, check this out. Is this a parallelogram based on what I just drew right there? Look at the arrows I drew. Is it a parallelogram?
Yeah, because they're,
Yes. So is it not true then, since it's a parallelogram, that this would be congruent to that and this would be congruent to that? Not all four have to be congruent to each other, just the opposite sides. And we know that about a rectangle, right?
yeah.
So because it had those four right angles, then it is definitely a rectangle. And because it's a rectangle, we know those sides are definitely congruent to each other. Now, it doesn't make it a square because I was saying left is congruent to right and top is congruent to bottom.
Yeah.
A square, all four would be congruent to each other and have right angles. It's like a rhombus. I always think of like a rhombus. If you were ever a kid and hid inside a cardboard box where you used it like a fort or like a ship or something like that, and ultimately one of your friends came and pushed down on the top of that or like jumped on it, and it like gets all squishy and floppy afterwards, it's like that. It's like a box, like it's just lost its right angles. It doesn't stand up straight anymore. It's kind of like a floppy cardboard box. Okay, this is what I think is the number one most important study tool, and I'm going to add to it right now. And so here are the things that you know, and we're going to add to it every single time we run across a new lesson. You're going to see this, and we're going to add more and more. So here are the things that we know about parallelograms. So this is the way Venn diagrams work. Like notice that in the group of parallelograms, we have rhombuses, squares, and rectangles, which means all three of them are parallelograms. And rhombuses have four congruent sides. Rectangles have four right angles. Notice that a square falls into both of those, so a square is both a rhombus and both a rectangle. But here's the things that I want to add on. So the definition of a parallelogram is that the opposite sides are parallel. And let's just give ourselves some notes here, all in one picture of what's true. Okay. The opposite sides, bless you, are congruent. We know that to be true as well. We know that the opposite angles are congruent. We know that the diagonals, let's say diags, bisect each other. I'll use little dots here to separate the ideas. There's 1, 2, 3, 4. Well, let's see. There's 5 that I should have. Or what's the 5th one that I'm missing? Oh, yeah, go ahead.
The one pair, the pairs?
Well, that's a way to tell something is like, but this way, well, the other one that we don't have here is that the consecutive angles are supplementary. All of this is true. All of these things are true about every single parallelogram. So it's true for rhombuses, it's true for squares, and it's true for rectangles. If I have a rectangle, rhombus, or square, all these things are true. But we're going to get more specific now. More specifically, even more than that, if you are a rhombus, you are definitely a parallelogram, but you gain an extra ability. Your extra ability is that you've got 4 congruent sides. That happens for all rhombuses. Now, it doesn't mean that all parallelograms have that. Remember, a rhombus is a very specific type of parallelogram. Rectangle is a very specific type of parallelogram that has 4 right angles. And a square is both a rectangle and a rhombus, so it gets the properties of the parallelograms, it gets the properties of the rhombuses, it gets the properties of the rectangles, which means this, 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 this. A couple other things that we are going to learn, and we are going to add them on, is that in a rhombus, the diagonals, this is an additional thing. It's not contrary to the others. Additionally, the diagonals are perpendicular, meaning that these diagonals here will form 90-degree angles. That will be true. For every rhombus, the diagonals will be perpendicular, and the diagonals bisect the opposite angles. So the two that are across from each other, These are being bisected. Remember, Colette, you asked me about angle bisectors? That's true for a rhombus. So let's say this one has 2 marks, that has 2 marks. I only use 2 just to separate that it's not like one big line there. Yes, ma'am?
I just don't like it doesn't make sense to me how like a rhombus could have 4 congruent sides if it's slanted. 'Cause, like,
Okay, so imagine again, like, have you ever hidden inside a cardboard box when you were a kid? Okay, so let's say that this is your cardboard box, okay? And you're sitting inside it, you're having fun, you're playing whatever little game you're playing. There's you. And you're very happy. You've got your hands on your cheeks and you're just laying inside this cardboard box. Yay! But then, you have an older brother or older sister? Which one? Older brothers are fantastic at doing this. They love to come and do a wrestling move and jump on top of this box when you're in there because they think that's funny. But what happens is, imagine like if this box has 4 congruent sides, right? And you're in it, and your brother comes and jumps on it. Well, now your box kind of got floppy like this. So you're still inside there, but now you're sad because they broke their box. But it didn't change the length of the sides of the box, right? Like it doesn't change the length of the box because somebody jumps on it. Those lengths are still the same. It's just floppy. The angles inside changed.
In a rhombus, are all the opposite angles congruent to each other since the diagonals are bisecting them?
Because it's a parallelogram, the 2 opposite angles, lower left and lower right, are congruent. Upper left and upper right are also congruent, and upper left and upper right are bisected. So the upper left and upper right have been bisected, and the same with the upper left, lower left, and upper right. So like notice that like this piece and this piece are the same. Same with this one and this one. The same will be true about this angle will match this angle, which will match this angle, which will match that angle.
All 4 won't match.
Right, they won't all be the same thing. Because here's what's happened. Think about this box. When I came in like, here's your brother jumping through the air and about to do a body slam on top of the box. What happens is, as they crush this side of the box, this angle gets smaller, but this angle is ultimately getting bigger, right? Like those angles change inside the box. One gets bigger, one gets smaller. The ones opposite each other, like these 2 right here, would get small because that's going to squish down, and these 2 would get really big. But it would still maintain the same amount of degrees. It's just the opposite angles. 2 of them would get smaller, 2 of them would get bigger. Amber, you got a question?
No.
Okay, so additionally, there's something we learn about rectangles, and that it will always have congruent diagonals. That's true for a rectangle, meaning that this line here, the whole line, will always be congruent to this line here, the whole line there. So remember that we already know that these are bisected, that they bisect each other. So this is the one scenario where we get this. If they're both the exact same length and they both bisect each other, then all 4 of those pieces must be exactly the same. 2 exact same pieces split in half will have exactly the same halves, right? If I have a stick that's 10 feet long and you have a stick that's 10 feet long and we split them both in half, we have 4 pieces that are all the same size.
Are the diagonals of rhombuses, are they congruent?
Not necessarily. The only rhombus that we can say that the diagonals will be congruent is if that rhombus is also a square, because a square is a rectangle and it's a rhombus. So you can see that there's going to be a lot of rules adding on here. So we're going to learn all about those. We've got diagonals are perpendicular for rhombuses. The diagonals bisect the opposite angles. And for a rectangle, they have congruent diagonals. So you can see there's a lot of things here. This is kind of what I think is the best area to contain all your information that we've learned so far. It's going to grow more than this. Okay, so remember here are the things that I just told you. A rhombus has diagonals that are perpendicular. In a rhombus, the diagonals bisect the opposite angles. That's what we see here. Notice this angle has been bisected, this angle has been bisected, this one's been bisected, and this one has been bisected, just like we said. And then finally, in a rectangle, not only do the diagonals bisect each other, but the entire diagonal is congruent to the entire diagonal. So if this whole piece is 30 feet, then the other one is 30 feet as well. And each one of those little pieces would be 15 feet because each one of them has been split in half. So I could say each one of them is 15 feet. And it makes a whole bunch of like cool little triangles. I can go, oh, I can start solving stuff now. What's great about a rhombus is, you know what happens when I get these perpendicular things in here? What's special about all the triangles that it made in there?
They're all 90.
They're all 90. All right triangles in there. And we can start solving those. Back? Okay, sorry. I'll pause there. Okay, quadrilateral ABCD is a rhombus. So I know it's a rhombus. It gets everything that a rhombus gets. It gets everything that a parallelogram gets because this is a parallelogram. Every rhombus is a parallelogram. Is every rhombus a square?
No.
No, every square is a rhombus, but not every rhombus is a square. That's what our diagram shows us. So we need to find these things. Quadrilateral ABCD is a rhombus. Find the measure of each angle. Now, here's my theory, and you don't have to stick with this. I do not like to go to what they're asking me first. I like to mark everything I know about this before we even start. Now, remember, it's a parallelogram. So everything that you learned about parallelograms is also true here. But additionally, the rhombuses. So tell me some things that are true. Okay, good. So we've got that. They've been bisected. Remember, the reason I didn't do 4 is because this is not a rectangle. And he said perpendicular. So I'm adding these things in there. All of that is true. What else? What else do we know about a rhombus? Yes, ma'am.
Well, since it bisects the opposite angles,
Good, I'll do that. This is what, so bisects the opposite angles. That means this and this, this and this. So check it out. What she just gave me, I'm just going to fill this in because if it's being bisected, then this is 62, and this is 62, and this is 62. All that she just got from what she just said. She said those angles are being bisected. Great. All of that must be 62.
Are they bisected in a rectangle too, like if they have design?
Not necessarily. The only one that will be bisected that is also a rectangle is a square, because a square is a rectangle and a square is a rhombus, so it gets that too. So is there a rhombus where they're bisected? Yes, it's a square. So we have to kind of look at what we have. Yes, ma'am. What else?
All the 4 sides are congruent.
Good. All the 4 sides are congruent to each other. Now, notice that I'm using 3 lines because I'm not implying that it's the same as the one that's marked 1 or the one that's marked 2. Anything else that we gain? Yes, sir.
So because it's a 90-degree angle, we could add 90 and 62.
Beautiful. So he's saying, like, I got these triangles. I have 4 triangles in there. And he's saying that each one of those triangles has a 90 and a 62. So 90 and 62 is 152. And 180 minus 152 tells me that the last remaining angle here, 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 and here must be 28 degrees. Because there's 4 triangles. And in each triangle, I had 3 angles. And they were all the same thing. See, we're getting a lot of information here. Now, if I'm not mistaken, everything on the left asks me about angles. And I know every single angle in there at this point. So I'm not going to keep going and try to figure out information about sides, which I don't have any information about sides. Let's just answer those questions now. Because now I've done my picture. ACD. ACD is this one. ACD. How much is that? 62 degrees. DEC. Let's see. DEC is DEC. How much is that angle? 90 degrees. And then we've got EDC. Where's EDC? Is that angle? How much is that? And then finally ABC. So take a moment, because it shouldn't take you long, but it does take a little more thought than the others. 56, because that's 28 and 28. So I can tell you right now, when people get stressed out about this one, it's because they started on the left and they're like, they want ACD. Like, I always go, just let's fill in everything we know. Here's what I know, and now let's see what we can do with it. It's like a crime scene, right? Like, they're trying to figure out what information do we know? How much stuff do I know? Let me use that information now. Yes, ma'am.
I thought that the angles were supplementary. Oh, I got time.
Gotcha. Yeah, so when we say supplementary, they still would be supplementary, but it's this and this. You see what I mean? Those two would be supplementary. Or the top and the bottom one on the right, or the top and bottom one on the left, or bottom left and bottom right. But you can't just pick 62 and 28. It's the whole angle in the upper left, the whole angle in the upper right. Can I move on? Okay. Quadrilateral MNOP is a rectangle. So now we're going to do all the things we know about a rectangle. So, yep, what do you got?
Diagonals are all congruent.
The what? The diagonals are all congruent. So the whole diagonal is congruent to the whole diagonal, which means this whole line is congruent to that whole line. Okay, that's good information. What else? Talk to me more about the diagonals.
Each diagonal, they're all congruent. Each diagonal.
Each segment of the diagonal is also congruent right there. So now that I know that each one of these is 12, how long is each diagonal? 24. Now notice that all 4 of those triangles are what kind of triangles? Look at those sides. It's an isosceles triangle, so we know something about the base angles already. So now we do know that it's a parallelogram. So we also know that rectangles have right angles in the corners here. So check this out. If this is 29 degrees, how much is its next door neighbor? Not 29.
90 minus 29.
90 minus 29, which gives me 61 degrees. Now remember, because this is a parallelogram, we get those same opposite angles, those alternate interior angles, meaning that this would be 29 degrees and this would be 61 degrees. That same thing that we already knew. Okay, let's see what else we have. Let's see which questions we can answer. So the opposite angles are congruent. So we know, let's see, they would be supplementary. We know that these are already supplementary. 90 and 90 is I'm just looking at what we have. The opposite angles are congruent. The diagonals bisect each other. We did that. The opposite angles are congruent. The diagonals are congruent. Okay, let's see what we can do. Angle PON. Let's see. Angle PON is definitely 90. Angle PMO, 61. Line segment PL, which is 12. Line segment MO, 24. I got a little bit scared there for a minute that they were going for the lower left angles or the lower right, and I was like, oh, okay, so what am I going to do about that? So we would have to find some other way of doing that, but that looks like all the information I could come up with from there. So we've got everything that we could do there. But all I'm doing is applying the things I know. If you don't know those rules, there's really no way you can go forward. So it's not hard, the math, it's hard knowing, well, what's true? And that's where your Venn diagram is going to come in. Can I move forward? Just say no if not. Okay. Okay, this is a square. So it gets everything that's true about a rhombus. It gets everything that's true about a rectangle. It gets everything that's true about a parallelogram, which is a lot of things to draw in there. So I'm just going to take a look real quick and see what they want to know. They want to find ME, that's this one over here. I know it's a square, and MO. All the sides are congruent, so I just mark those two as congruent. This is 7x minus 3. This is 6x. They want me to find x. Talk to me about that. Yes, sir.
7x minus 3 equals 6x.
Okay, so I'm going to add 3 to both sides. And we get 7x is equal to 6x plus 3. I'm going to subtract 6x from both sides, and I get x is equal to 3. That was easy. If MT, okay, here's MT right here. If MT is 4x, and TE right here is 3x plus 2, find OE. Okay, so this is 3x plus 2. This is a square. Talk to me about a square and the things that we know about a square.
All the diagonals that are bisected, they're all congruent.
Good, but wait a minute. First of all, I totally agree with you before I say this. I thought that was only true for a rectangle. A square is a rectangle. That's why we need to separate that out, is that sometimes people will be like, but wait, why are those two pieces congruent to each other? That's only true for a rectangle. A square is a rectangle. Keep going from there.
So you want to do
Good. Now we need OE.
So you want to plug it back into either one, so you can do 3x plus 2, and then you want to do
Now, she could have plugged it in the 4x too. She'd still end up at the same place. Like she said, she could plug it in wherever she wants. She's right.
that gives you 8.
Okay, so this piece is 8.
So then you just want to multiply that by 2 because they're congruent.
Good. All of these are 8, so she can just take 8 and multiply it by 2, and then she has the whole line, which is
Gives you OE, which is
16. OE equals 16. And that's it, my friends.